So, good morning, ladies and gentlemen. My group will introduce to you the datasheet of the 3-axis magnetic sensor KMC58830, alright? Which is basically a small and accurate sensor magnetic that commonly used with an Arduino or a decoder to show that information on a display or just read some information about the position of something. It is usually used for compassing, navigation, radars, gaming in drone, robots, or even metal sensors, alright? Looking down here on features, we had the most commonly searched things that people look for when considering buying this component, like the configuring like 16-bit analog to digital converter, the wide magnetic range field, and compatibility modes and things like that. On benefits, you find the most advantage that its component has comparing to other ones we have on the store. All right. If you are considering buying this component, be aware of reading these two sections. On the external schematic diagram, we have a little function in blocks that show how does the component works. We have three axes, three magnetic sensor, one for each axis, X, Y, and Z, that pass the signal through a multiplexer that sends all the signal into one line, that pass to an amplifier if you need to, and a 16-bit analog to digital converter that sends the signal through a signal conditioning for the register to read that. And then the Arduino or the decoder will read the signal on the register, alright? We have another information like VDD, input or output, VDD, GND, and things like that down here, the clock. If you need to read that, just be aware of reading the data sheet. Alright? And then down here we have the block function. The block, it's abbreviation, and his function slash definition. Alright?
Now talking about the electric characteristic, the supply voltage is 2.16 to 3.6. Seriously, the voltage of 2.7, 2.8 volts. Standby current is 3 microamps. Sensor range is minus H to H degrees. The sensor works in three axes, X, Y, and Z. So, to finalize, I talking about the Maximus ratings. VDDIO is a min 0.3 and max 5.4. The VDD is the same. Storage temperature is minus 40 and 125 is a max temperature. Exposed to magnet fields, all directions is a 50,000 graus.
Okay, my name is Leo, and now let's see the package pin configurations. I mean, how the pins are physically. Here we see the package 3D view, where the arrow indicates the direction of the magnetic field. Then we see the then we see the pin information, the number, the name, and the function of each pin. And down here, we have a top view of the component. Then we look at the package outlines, the size and the type, and we have a top view, down. Then we have a top view, a bottom view, and a side view of the component. Uh, then we see the marking. That is how we see the tracking code in the component, how the numbers will appear at the screen to us. In in external connection, first we see the dual supply connection with a host CPU, where the VDD is connected on a capacitor, and then the single supply connection, where the VDD is connected with the VDD I/O, how we see there. And then we have the some mounting considerations. Here we see the recommended PCB footwork, that is the printed circuit board footwork.
My name is Felipe, and now I'm going to talk about the working about the components. Normally, this type of sensor is used to inform the brain of the circuit the position of something referring to the magnetic field. To work, the sensor needs the VDD to be supplied with a voltage between 2.6 volts, and 3.6 volts. The VDDIO, or the VDD about the brain of the circuits, needs one voltage between 1.65 volts and 3.6 volts. The sensor has a system to compensate for the temperature changes. Therefore, the temperature does not interfere on the rail uh, of read of magnetic field. The device has two operation modes that can be changed through ODR09H during the program. The first mode is continuous. In this mode, 098 is 1 and the sensor does not stop the magnetic field. The magnetic field is showing as a DRDA bit in register 068. The second mode is the standby mode. In this mode, the sensor doesn't work and the device only shows the last medition. This mode is for save energy when the sensor doesn't important. And if you need, the page 12 and 30 has some graphics that shows the behavior of the component on both modes.
So on page 13, we have topic 7, and in this topic, talk about application exams. Some of these exams are continuous mode settings, measurement, standby, and soft reset. On the next page, we have the topic H, I2C communication protocol. This topic talks about I2C times and I2C RW operation. In I2C times, we have a table and a graph with the component data. And in the I2C RW operation, we have a table with the abbreviations used and how to start, stop, EC, and NEC operation. Right after that, we have on page 15 how the data is writing and read informations. In addition to the pointer rule over of the component, all these accompanied by their respective tables. On page 16, 17, and 18, we have topic 9, register, and in it we find the register map and register definition, such as output data register, stats register, temperature data register, control register, and set reset period register. These are very important information when you will make a circuit. And on page 19, and last of this data sheet, we have the ordering information in addition to the quotients and some contacts for more information.